Day 260 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 108, convert sorted array to binary search tree. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand. So let's get into it. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check that link out in the description. Now let's see what the question says. Question says, given an integer array nums where the elements are sorted in ascending order, convert it to a height balanced binary search tree. Okay, sounds simple enough. So let's look at example one so we can see what it is exactly that they're talking about, right? And the first thing we need to do to understand what they're talking about is we need to know what a height balanced binary search tree is. So let's look at the definition. It says a height balanced binary tree is a binary tree in which the depth of the two subtrees of every node differs by no more than one. Or excuse me, differs by more than one. Sorry, never differs by more than one. So let's break that down and let's see what they want us to do, right? So as we can see that in this picture, right, this is actually a picture of the output. So this is a picture of a height balance subtree. As you can see, it's height balance. And same, this right here is also a picture of a height balanced binary search tree. And as you can see, it's height balanced as well. So let's get into it and see how they got this, right? So in the input, we have nums equals an integer array with the integers being -10, -3, 0, 5, and 9. The output is a binary search tree, height balanced by the way, and that is 0, -3, 9, -10, null, and 5. As you can see, we have that right here. We have 0, then we have -3, we have 9, then we have -10, then it's null right here, then we have 5 right here. Explanation says a binary search tree of 0, -10, 5, null, -3, null, and 9 is also accepted. And that's what we have a picture of right here. We have the 0, -10, 5, then we have the null right here, then we have the -3, then we have the null right here, and we have a 9. So it's not that difficult. We just want to turn this array of integers into one of these outputs of a binary search tree, height balanced binary search tree. So let's look at example 2 just in case it gets a little tricky or something. We have less integers. So in example 2, we have the input nums equals an array of integers 1 and 3. This time the output is a binary search tree 3 and 1. Explanation says 1, null, 3, and 3 and 1 are both height balanced search trees. So as you can see, I don't know why they did it opposites like this, but this binary search tree right here corresponds to this binary search tree on the right. This picture on the right, we have 1, then we have null over here on the left subtree, and we have 3, but they're both height balanced because it says never differs by more than 1. So even though this is null and it's 1 over here, it's not more than 1. Now if they would have had say it was another node over here, say it was like 5 or something, and everything on this side was null, then it would not be a height balanced binary search tree, because then the height would differ by more than 1, right? Same on this side, we have 3 and 1, so we have the root is 3, then we just have the 1, then it's null over here. That also counts as a height balanced binary search tree because the difference does not differ more than 1. Right now, if we had, say we had something else over here, again, say it was a 5 or something over here, that would not be a height balanced binary search tree because the height would differ by more than 1. So let's get into the solution, y'all. Now that we understand the question, let's get into the solution. Now the solution is not that difficult, y'all. So let's get started. First thing we need to do is we're going to need to create a helper function that's going to allow us to recursively go through this input that they've given us, right? So in order to do that, we're just going to say private func. We could call it helper because it's our helper function. Then we're going to open up the parentheses. We're going to say underscore nums. We're going to set that as an array of integers. Boom. Come outside of that. We're going to say comma underscore. We're going to create another parameter. We could call that low. We're going to say colon. That's going to be an integer. Then we're going to come outside, underscore, create another parameter called high, and that's going to be an integer as well. Then it's going to return a tree node. Boom. Put a question mark after the tree node. Tree node's coming in from this public class up here that they have given us. Now, let's open up the brackets and let's get started on the function, right? So the first thing we need to do is we need to create a base case to see if the lower index exceeds the higher index, and if so, we could just return nil, right? So in order to do that, we're just going to say guard low is greater than, less than or equal to high. Not just high. Open up the parentheses, high. Just high. Guard is less than or equal to high, else open up the brackets, we can return nil, just like that. Now we need to find the middle element of the current range, right? So in this case, we need to find this 0 so that we will be able to build the left subtree and the right subtree. So in order to do that, and when I say find the 0, I'm saying we find the 0 because it's in the middle. So we have two integers on this side, we have two integers on this side, and we have the 0 in the middle. So this is how we find that middle index, right? We're going to say let mid equal low plus, open up the parentheses, high minus low, and then we come outside of that and we could just divide it by 2, just like that. Now we need to create a node for that middle value that we just found, right? That middle integer. We need to create a tree node, turn that into a tree node, right? So in order to do that, we're going to make it the root, and we're going to say by saying let root equal tree node, open up the parentheses, nums with an S, square bracket, mid, just like that. So now we've created our tree node, or we've at least created the root of the tree node. Now we need to create the left subtree. So we're going to create the left subtree using a little bit of recursion, but it's not that difficult, y'all. All we have to do is say root.left equals helper, that's the recursion part, open up the parentheses, nums, comma, low, comma, mid, minus 1. And once again, that's going to construct the left subtree using the left half of the array. So this right here is going to come, it's going to see the 0 as the root, it's going to check this left half of the array and create our left subtree for us. Now let's do the same thing for the right subtree, right? So in order to do that, we're going to say root dot right equals helper, open up the parentheses, this time we're going to say nums, comma, mid, plus 1, comma, high, just like that. And now we need to return the root node of the subtree. So in order to do that, we're just going to come right here and we're going to say return root, just like that. But we're not done yet because we still need to actually call the helper function in the main function. So in order to do that, we just say helper, open up the parentheses, nums, comma, 0, comma, nums, dot count minus 1. Boom. Now that should be all she wrote. Let's run it. Make sure it runs like it's supposed to. Let's see. And it's accepted, so let's go ahead and submit it. Make sure it stays accepted, because as we know, that's not always the case. All right, and look at that, y'all. 1 millisecond beats 29.23% of users with Swift, y'all. Don't worry about those numbers right now. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that's been put in front of us. And I figure this is a good solution for that. Easy to understand, easy to learn from this solution. So make sure y'all internalize it and understand everything that's going on. It's pretty simple. We just find the root, then we create the left subtree, then we create the right subtree, right? Find the root right here, then we create the left subtree, then we create the right subtree. We find the root right here and turn it into a tree node right here. Boom, just like that. It's that simple. So get one more look at the code, y'all. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.